to the club. Okay, hello everyone. Welcome to SD Skills. So in this session of SD Skills, we are going to discuss about the system design concept and which is service mesh. So let's get started. So basically, first, before we delve into what is service mesh, first let's get to the fundamentals. That why do we need something like a service mesh, right? Why is it so important? So, and before going to that, first we have to understand the difference between monolith and microservices. I think we all are aware of microservices, right? Basically breaking down code, a big chunk of code into smaller independent units so that each team can work on those independent units. And this basically speeds up a lot the deployment and everything in an organization because each team is working independently on their component. So they can deploy at their own pace, right? So this gives faster deployment and all those things to organization which is using microservices as an overall architecture of their application, right? But interesting thing is, can anyone tell me like why would we not choose microservice and why monolith is better and some of the problems with microservices?
For small scale applications, we can use monolithic. Microservice will just complicate the application structure if it is a small scale application.
Yeah, definitely. That makes sense. Yeah, and Jialu,
one of the reasons I can think of is a noisy neighbor. So if we deploy two containers which consume large amount of traffic on the same pod, this may introduce some noisy neighbor issue.
Yeah. Okay. So noisy neighbor is one problem, but do you think it's problem with only microservice? I mean, if you have one monolithic code and basically if you are getting a lot of requests, so in microservice, that big monolithic code is divided into smaller units, right? Now in a monolithic code also, if you are getting a lot of requests for some particular for some particular thing, there also your system will be overloaded if there are multiple instances deployed on the same machine, right? So basically, noisy neighbor is that in a multi-tenant environment, same machine is hosting multiple tenants. So there are multiple instances of that service running on the same machine, right?
Yeah.
And if one particular tenant, it is giving a lot of requests, the other tenant is not able to serve users' requests, right? So that could happen with a monolith also, that if let's say I have two instances of monolith, basically in a one machine, I have two VMs. In one VM, I am running the monolith for one tenant. In another VM, I am running a monolith for another tenant on that same machine. And so again, if that one tenant is sending a lot of requests, I think the other tenant will suffer. So I feel maybe that applies to both of these.
Yeah, makes sense.
Okay, so that's great. So another point I want to mention, and basically like in my team, we don't use microservices. So I'll tell you why. So basically microservices communicate over network, right? So basically you have these smaller components that will be deployed on different machines. And maybe those machines are on a same data center. So their latencies will not be very high, right? But still there is this network communication, right? So that's the thing with microservices, and network is unreliable. So this introduces basically the problems of any network that you will face with any system which communicates over network, right? And I mean, also like this network communication, it adds delays, right? Although in a same data center, but it will add those small delays. So like I am basically part of Azure storage team. And so storage team is the basic fundamental storage being provided to the customers. And so for us, like latency is very important because people build applications on top of storage, right? They use underlying storage and they build applications on top of it. So if like any milliseconds saving of latencies in this underlying storage, like brings the goodness to all the users which are using us as an underlying storage. Whereas I see as application developers, if you're developing applications, then basically few milliseconds of latency does not matter to applications, because as long as to a human visible eye, you don't see the latencies and those milliseconds of latencies don't matter, then it's good. And you want to more focus on developer agility and building your applications faster. So in those kind of scenarios, I feel microservices are great because you want to build things faster. But some teams like which are providing this core underlying storage systems, there if your system is very latency sensitive, there like microservices may not be the best thing for you. Is that fine? So with that, so now, but this discussion is about microservices. So if we are using microservices and microservices communicate over network, so how do we deal with all the issues that are there with the network, right? So that's the thing, that all the issues that can arise in a network, those things, rather than application developers, they handling all those details, they can directly use a service mesh, right? So service mesh is basically that application developers focus on their business logic and using an existing common functionality, which provides all the features related to microservice communication. And later we will see that what all great things we can build in a communication layer, right? So if someone provides all those goodness in communication layer, we will get a lot of our things for free, which like lot of organizations have special teams for each of those components, and using service mesh and these kind of things, like they can get all of that for free. Right? So basically, service mesh is a dedicated infrastructure for facilitating service-to-service communication between microservices, right? And it uses a proxy so that it intercepts all the inbound and outbound requests before basically sending it to other microservices. Okay, so now moving to the part where I was saying that what are the functionalities and important things that a communication layer can provide. So, so yeah, this is the list, and basically let's discuss one by one. First is traffic control, right? So basically, when we make a request over a network, we have to deal with these kind of issues, that load balancing, right? That which microservice replica should my request go to, right? Then second is like rollout. So basically, if we have multiple instances of microservices, one having V1 version of our service, one having V2 version, and we want to gradually roll out to V2 version, that is also part of communication in a way that we will only send, let's say, 5% of the request to V2 and 95% of the request to V1. And as we see that the system is behaving well, then slowly we will roll out more of the request to V2, right? So this is something that the communication layer can handle easily. The other very important part is service resiliency. So in microservice architecture, when basically one microservice communicates with other microservices, it's making a request, right? And in a network, that request can fail, right? or that request can have high latencies and all those things, right? So either the application developer, he has to write a business logic in every piece of request that he makes, that if this request fails, retry again, right? And retry it 3 times and do exponential backoff and do a circuit breaker and all those things, right? So imagine in microservice architecture, you are writing a lot of this code that make a RPC call to another microservice, and every time you have to basically either write your own code or you are writing your own shared libraries to do all this retry and all, right? So again, you don't have to do this with a service mesh, and it can provide you this common functionality. The third thing is chaos testing. So basically, if you want to introduce some failures in the system and test how your system is overall behaving, again, that can be handled in the communication layer in such a way that basically you fake. So for a particular request that you make to a microservice, you can fake the response saying that it failed, right? 5x or something, right? And so rather than actually modifying the code in the communication layer, we can make some of the components behave as if they're failing and see how our system is doing, right? So that is chaos testing. Fourth part is observability. So observability here is, so basically when we are making requests between microservices, right? We need to know what was the latency. So in the entire flow of request, my request would have gone to different microservices, right? So having a track of what was the request path, what was the latency in each of the microservice component, where did things fails, right? And having that lineage of logs, that what was the entire dependencies in your microservices, that all will provide you observability in your system, so that for metrics debugging, you can use those kind of functionalities. And again, that is provided by service mesh. So you can use that functionality of service mesh. And the last part is secure connection. So basically, this networking communication, it should be secure, right? And all the data that is transferred between the microservices, it should be encrypted, right? So again, that functionality could be provided by a service mesh. Any questions so far? Okay, so I'll just, these are some names of some famous service mesh products. So in this, we are going to discuss about Istio, right? But there is Linkerd, Council, AWS App Mesh, and Open Service Mesh. These are some of the famous service mesh products. Okay, so now I'm going into like one level deeper of basically how the functionalities that we discussed so far, how we can actually achieve them in Istio. And before I go this one level deeper, like you'll see how easy it is to do all these things through a service mesh. Like there will be hardly any code. Everything would be done in some config files. So you just change few lines in your config files and you get all of these functionalities, right? So yeah, so we'll see how basically these things you can actually do if you're using Istio as your service mesh. Okay. So yeah, so basically just a little info on architecture of Istio. So basically it has two main components, a data plane and control plane, right? So so like let's say you have this microservice architecture and you have defined your pods and your microservices are running in containers inside the pods, right? So with Istio, you will create a sidecar, and this sidecar will be your proxy, and it will have all the common functionalities that your microservice needs, right? So this sidecar will be attached to your microservice, and then the microservices, they will be talking to each other through this envoy sidecar proxy. So they will not be talking to each other directly, but using this envoy sidecar, right? So this envoy proxy part and this sidecar, this is the part of data plane. And then there is another component, which is control plane. So control plane is like all the configurations and everything, the centralized thing that your system should have, right? So Istio has three components in control plane: Istio pilot, Istio mixer, and Istio CA, right? And like we'll see more about these in few seconds. So yeah. So again, so data plane, it has two main components: service proxy, and as I told, application goes talks using service proxy whenever they want to communicate over network, right? And the second part is sidecar, which is another Linux container, and it is attached to your original container. And basically, this is responsible for intercepting all the inbound and outbound. So this is one interesting representation that before Istio, right? If you are building your microservice, so inside a container, you will have your service code, and then you will have like these functionalities: load balancer, service discovery, resiliency, metrics, tracing, all of that. You will have this piece of component in your microservice, right? And each microservice will have these kind of common functionalities. So with service mesh, basically your container only contains your application logic, and all of these common functionalities are living in a sidecar, right? And so this is how your new system is.
Hey Abhishek, so is the sidecar more generic or specific to that container?
No, it's generic. So every container will be using that same sidecar. It will have common functionalities, but yeah, you will attach. So basically, this as a system, you have to attach this sidecar to all of the containers.
Hey, Abhishek, I joined actually a little late, so can you just spend a minute? So Istio is like kind of competing with Kubernetes, or it's like in addition to Kubernetes, or like how does it compare with Kubernetes? Because
Yeah. So good question. So like according to what Istio's documentation, so wherever Kubernetes stops, Istio starts from there. So like whatever are the functionalities that Kubernetes does not provide, Istio augments on top of it and provide those additional uh, features and functionalities, right? So basically, briefly, I was discussing that uh, a major part of microservice architecture is that microservices want to communicate with each other, right? And when they do the communication, there are a lot of common things, like they want in the communication, you want retry, back off, you want gradual rollout, and all those things, right? So I see that some of things have overlap, like load balancing and rollout. These things could, I think, are also provided by Kubernetes. But some of the things which are not provided by Kubernetes, like automatic retries, back off, observability, and all those things, these are the things that you use Istio for, right?
okay, all right, okay. So somebody will either use Kubernetes or use Istio, right? It'll be
No,
that
no,
way.
they will use both. They will use Kubernetes.
No, it doesn't work that way. You build Istio on top of Kubernetes. So you should already have the technology in place. So what Istio does is it uses the sidecar technology or concept where you remember in olden days, there used to be a scooter or a motorcycle with a sidecar, right? Additional people can go. So the same concept is used here, where all the common functionalities or anything that you want to add on, you either put it in a sidecar or you put it in a common place, and you just take the product, make the product as simple as possible, and everything else you put it in a sidecar.
Yeah.
So this sidecar is a microservice component again?
No, it's
or
a
is it
Kubernetes side.
No, it is what language normally people build using sidecar?
A sidecar, basically you use Kubernetes pods. You can visualize that as another pod, but it won't run without the original pod.
Okay, so adding a one more layer in as a sidecar, it can cause a latency, right?
No, generally what we do is, supposing originally when you add Kubernetes, all your observability, everything, metrics, everything is in one pod. So with sidecar, what they do is they do all that logging and other common security. You all put that in the sidecar, and main service, you don't have to concentrate on that, and you can easily change the sidecar based on your team's security and observability metrics, whether you use Grafana or Prometheus or something.
So you mean the main container won't have the Grafana metrics?
The main container will talk to the sidecar and get everything done.
Okay.
So you don't have to custom build for your service. If you're using same technology across your ecosystem and you want ecosystem to be observable across the domain, then you can use sidecar and actually use that.
So just one more question. So communication between one services to another service, suppose we use some TCP or two-way SSL certificate. So is that goes to sidecar as well?
Yes.
Okay.
So how does the discovery happen using the sidecars? So the sidecar communicate to like some system or?
Yeah. So basically, a few things.
So it is configurable, right? So basically,
yes, it is configurable, and both are integrated. Both are integrated as one. So to get it going, you need both working. If you want to use this framework, you have to use sidecar.
Okay, say if my microservices is using like HTTP dot, say some awesome microservice. So you have to configure that awesome in the configuration, but it would be too specific to pod, right? So how would it know like where it needs to communicate to other microservice?
So what communication are you looking for between other microservice?
Say if I say that my microservice provide the shopping capability, right? So some say choose a product, and other microservice it want to call the payment, right? So how does this service sidecar knows like where to call that other service? So
yeah, so that service discovery, it's part of control plane. So when I discuss control plane, I told you there are three components, right?
Okay.
So this control plane, yeah, so we are moving there. So just to answer a few of the questions, yeah, this sidecar is also a container, right? So it's also that small microservice. And each of this sidecar container, it is attached to your microservice, right? So you need to have this, and then you can basically have all the common functionalities in the sidecar. And then second part is, so your microservice, although it will make a request to another component, so from shopping to payment, it will make like how it is going to make a request to the payment service normally. But internally with this design, the request will not directly go through it, but it will go through sidecar container, which will proxy, so which will basically intercept the request. So think of it as that you have attached Fiddler in your system, right? So you are making normal request in your system, but then Fiddler has intercepted your request. And now in Fiddler, you can define the rules, whatever rule you want to make, right? So this has acted like that interceptor. So you are making the request normally, it will intercept, and then based on the rules and everything that you define, it will then send the request to wherever it needs to send the request.
Oh, okay. So the container that we are building microservices, do we need to configure the side that it has to communicate to sidecar, or it can exist independently? Like say if I want, use Istio, right? So I don't want to, for now I want to use Istio, and then later I decided I don't want it. So the container can still exist. Without any change, we can deploy it anywhere, or is it going to be like some changes that we need to make to adapt?
Yeah, you would need to make those changes. So when you are using Istio, so you would do the initial setup and initial installations, and basically all the changes in the configuration and all about how this communication happens.
Okay.
But your microservice, your container is living separately. So this code logic, that will not change. Only your configuration files and most of those things change. So when
Oh,
you're trying to remove the sidecar Istio, then I don't believe, or there will be very little changes in your actual business logic code, but you just need to make changes in the configuration files and such, and then you will be good to go and remove it.
I have one question regarding these load balancers. So is it like there are multiple instances of the service within the pod, and then its load balancing is happening for that?
We'll discuss that in detail, like we'll go that in very detail. So load balancer is there in service resiliency. So, okay, so let's take it up there.
Okay.
Okay, so now from data plane, let's move to control plane. So control plane is basically the set of configuration files and all that you want to store for your Istio configuration. So it has three main components: pilot, mixer, and citadel. So pilot stores, basically it has information about what all microservices you have in your system, right? And so basically it keeps that mapping and routing table of what microservices are there. So then this can provide you service discovery, right? So in this architecture, you will see that Istio pilot, it also lives as another microservice, and it is deployed as a pod in your Kubernetes cluster, and it is responsible for keeping all the visibility of all the microservices, right? So then the second part is mixer. So mixer is something, as the name suggests, mix. So it brings everything together in such a way that all the logs, so every of your Envoy sidecar microservice that is attached to Envoy sidecar, it is collecting your logs and telemetry, right? So all of them report back their logs and metrics to Istio mixer, which then collects them, right? So the responsibility of Istio metrics is bringing all the telemetry back to mixer, and basically you can also define usage and access policies for your microservices, right? And then there are some additional functionalities, like you can also add rate limiting rules and all those things in your mixer. But yeah, that's more about it. And I was reading that they have defined mixer in such a way that it's basically you can extend the capabilities of mixer by attaching more components to it. So basically, yeah, it's like if you want to add more functionalities within the mixer, you are free to do that. Citadel is more for security. So so basically for each microservice, if you want to issue certificates, and basically for the security layer in your microservice communication, Citadel is responsible for that. Yeah, so basically this was little details about the data plane and control plane. So yeah, with this, now let's move forward to the functionalities that we were looking at and how basically Istio provided these functionalities. So one of the very interesting functionalities is traffic control. So traffic control means that if we are deploying to a new release, how do we gradually roll out our system to those releases, right? And so I think in every organization, you would have this kind of a system, canaries, right? So basically, you have V1 version of your application, then you make V2 version of your application. First, you want to roll out only to some internal users or some very less percentage of the overall traffic and see how your system is doing, right? So this you can do in Istio by providing these rules, right? So first, basically, you will define a destination rule file. In Istio, you will have a destination rule file. So this is a file named destination rule. And then basically your service name is recommendation service. So let's say you are building a recommendation system and you have a microservice which is responsible for providing recommendation, right? So you had two versions of it, V1 and V2. So you will define the labels that this is V1, which points to version V1 and V2 points to version 2, right? So having this definition in your system, now it's super easy. So in your virtual service, which is another configuration file, you will say that basically HTTP requests, right? So how do you route them? So you route them so the destinations that you have defined above. So basically the destination, which is version V1, give it 100% of the overall traffic, right? So this means that all your requests will go to V1, even though you have your V2 deployed in your Kubernetes, but all of your requests will go to V1, right? So now initially you had this kind of configuration. Now you built V2 and now you wanted to add some traffic to V2, right? So then this is simple. You will add this another line that destination, the host is recommendation, version V2, give this one weight 10. So your previous one had weight 90 and this one has weight 10. So now basically Istio will take care of routing the traffic in such a way that 90% of the requests will go to V1 and 10% to V2, right? Then you leave this configuration for a week or so, you see how the system is doing. If everything is doing fine, then now you want to increase the traffic to 50%. So you can do that easily, right? Okay, so the next thing is how will you route based on headers, right? So this another interesting scenario. Let's say we want to say that the requests that come from Safari browser, I want to route those requests to V2 because I have well tested my functionality on Safari browser and I have still not fully tested my functionality on other browsers. So for them, I will still keep them V1, right? So again, you can, so basically here in your logic, in your configuration file, you will say that match the request based on headers. And if header has user agent as Safari, then route the request to V2, right? Else the default routing is V1, right? So now basically your request will be intercepted, that only Safari's request will go to version V2. Now the third part, dark launch, right? So sometimes you want to release a version, but you don't want it to show to any customer, but you want to see that how, if you give actual live traffic to that version, you want to see how that system behaves, right? So either you have to mock the request, like whatever request the live system is producing, you have to mock those requests. That becomes difficult, right? In your test, you would have to mock those kind of requests. The other easier approach is you can mirror or echo your live request. So you will say to your system that, hey, my system served it through V1, but whatever request is coming to V1, also mirror that request to V2, right? The new version which I have. So your live customer traffic, it will be served by V1. And basically this system, it will send a request to V2 as well, it will fire that request and it will forget about it. So then you will have your logs and telemetry from the V2 system, and then you can actually validate that your V2 system was behaving as expected or not, right? So this is dark launch, that this V2 launch is dark, it's not visible to customers, you are using it for internal testing. So if you want to do that, this small piece of config file you want to add, that basically your default routing goes to version V1, but also mirror the request to V2. Yeah, so these all things, right? So this is all I had related to traffic control, which you can do simply by the configuration files. Anyone has any questions, or should we move to the next part, service resiliency?
Yeah, one question, right? So do we have similar configuration for console as well, or just for this?
What do you mean by console?
So you
mean, okay.
Yeah, one of the example of service mesh was console, right, in your above slides?
Console, sorry, where was console? Can you?
I think the examples, right, for service meshes.
Example of service meshes. Oh,
yeah.
I don't know about, so
okay.
Yeah, I don't know about council, that how it happens in council. But I think it's
okay.
similar. But yeah, I'm not sure.
Okay, thanks.
I had one question here. So when you say the mirror part, right? So just help me confirm the same. Basically, what it is doing is it matches with the payload, the headers, and then tries to take that response and send it to V2, right? That's what ideally it would be doing, right?
That was different. So that was routing based on header. So this scenario is basically you have your V1 version, which is serving live production traffic. Now you have built out V2 version, right? And you want to validate your V2 version. How will you validate your V2 version? You have to send some request to V2 version and see how the system is having response to those requests, right?
Got it.
So how do we typically do? Either you will write some test that this is your test data, send this kind of request and see what the response will be. But that is a lot of hassle. You have to write a lot of tests. Another way you can do is that I'm not writing any test. Whatever request I'm getting for my live production environment, forward the same request to this new version V2 as well, right? And the response will not be shown to customer, like it will be just fire and forget. So the response will just go away. But I can basically look at the logs and see how my system behave with this V2 version.
And just another, I missed the initial part. Maybe you must have mentioned it. The versions that you're mentioning here, where exactly are we putting them? Are we putting them on the services? Or where exactly?
Yes, so initially, basically, so there are two files, destination rules file and virtual service file. So basically, when you release a build, right? When you create a build of your microservice, that build will have some names that, let's say, when you build the version V1, the name is version V1, right? And then now you made some code changes, you created another build, and the name you gave that name version V2, right? So basically in the destination rule file, you will say that whatever is the name of the build, that name is labeled as version V1. The other build, it is labeled as V2, right? So now you have given proper names to these builds. So now basically you can refer to this as version V1 and this as version V2. And then basically in your virtual service file, in your routing, whenever you want to refer to version V1, so you will say that use version V1 to basically send the request to this version.
Okay, thanks.
So just a question. So in actually in production, we are getting we will have a problem like when you deploy one of the component, And I'll just explain the real scenario, right? I mean, so when you're upgrading any Java upgrade or something, so normally you will deploy one new pod with this version, right? So you will test it with the minimum number of traffic and make sure that system is up and running, and there is no with the latest version of Istio there is no problem. So that is the main goal here, right? Okay.
Yeah. So yeah, you're right.
So this mirror feature, right? What you're talking, we actually used that last year to run our system for almost 6 months before we actually run that for public. So what we did was we created a service for internal, and then we pointed that to our internal database, and we were validating that with production volume and database, and we had a dashboard which was validating both the production records and the test records, that the mirrored ones, and validating the data because we were migrating from Oracle to MySQL. So we did this mirror for Istio last year, and it was a great win for business for doing this.
Yeah, and definitely, I have not used Istio, but I have had a similar experience that basically we were migrating search from one system to another. So yeah, so when we were building this new system and testing it out, so we were mirroring the requests which were going to this original system and sending it to the new system. And then whatever the responses we were getting, we were actually doing a match that what are the document IDs that are returned by first system versus second system, and what is the differences in those documents, so that we can see like how our system is doing as compared to the original system.
Yeah, something similar, yes.
Yeah.
And one question, like this configuration, it's part of it's a YAML file or something, or is it what kind of file?
Yeah, it's I think
it's a YAML file, and you can easily apply it.
Okay. So when if you want to modify something, we need to redeploy the sidecar again, or is it picked up automatically?
No, you don't have to redeploy. You just have to update the virtual service.
Okay. So the configuration update automatically, if I have a V1 to V2, so just modify the YAML file and it automatically pick V2 version.
So, yeah, you have to modify the file and like basically update and deploy that file, but you don't have to redeploy your code. So microservice code will not be deployed, only you are updating this file, right?
Okay. So probably we need to restart the service, or is it picked up automatically?
It's automatically, right? It'll automatically kill itself, and it'll reduce all the traffic, and it will kill itself and then restart.
Okay, I'm not sure about that it kills itself or not.
Yeah, so how it happens is when you want to scale up and scale down, right? So when you're deployed some new service, right? So immediately if the pod is taking any traffic, it will gracefully finish that and not take any more, and then slowly it will actually generate a new pod, and then slowly offload.
But then this will result in the downtime, right? So if every time you are doing a deployment, so you said it kills.
No, it will always have at least one pod up.
Okay.
And probably the pod we will have a UI to see, right? I mean, so the sidecar as well as a UI to see all the running sidecar, or is it internally?
You have
no, everything you can see. There's observability. You have a dashboard for everything.
Oh, okay. Yeah, thank you.
Okay. Yeah. So
and one last question. When you say the mirror thing, do we get to mention the percentage, or is it going to be 100% of it will go to V2?
Yeah, that's a good point. So I have seen that. I don't know. There could be a way, but
so
yeah.
One thing is, if you want to do mirror, then you can actually put percentage, but no, when you want to mirror is mirror, right? There's no percentage wise. But when you want to do percentage, then you go to the upper one. what do you say, go one level up, you will see that if you just want to sell 10% of the traffic.
Point is that your live system will be getting so many requests, right? Maybe I don't need to send all the requests to my this new V2. I only want to send only 5% of the request. That is enough to test, right?
So you want to do A/B testing kind of thing.
Yeah, this system itself is A/B testing, but I don't want to send all the requests. I need to send only few requests. So
then there are some tags you can actually put it, because these are common, right? So maybe even though you're doing mirror, you can put a sub tag of 10%. I think there is a place for doing that.
Yeah. Okay.
These are all tags, right? So you can very much extensible.
Yeah. Okay, so now moving to the second part, service resiliency. So basically, this discussion will happen about what happens when we make a request to another microservice, and either it takes a lot of time to respond or it fails, right? And all those things. So how this system can help bring those common functionalities, right? So first part of service resiliency is load balancing. That basically you have multiple instances of your microservice and you want to divide the load, right? So some of the load balancing is provided by Kubernetes, and like this, you can use service mesh along with it if you want some to provide any more functionalities which are not provided by Kubernetes, or you can use Kubernetes as well, right? But here, basically, they support three kind of load balancing. One is round robin, which is the default load balancing. So round robin is clear from the name, right? One by one to each instance. Random is it will pick randomly one of the instance. The third is least connection. So in least connection, it will randomly pick any two instances of your microservice, and it will check which instance has less number of requests pending, and the system which has less number of requests pending, it will forward the request to that instance of the microservice, right? So you can choose any three of these approach. So to do that, the destination rule file that we defined above, you add this code, that load balancer and what should be the rule. Okay, second part is timeout. So basically, let's say you want to wait only for n seconds. If your microservice, it is taking forever to respond and you don't want to wait for forever, right? You want to say, I want to wait only for n seconds and then I will just respond as failed, right? So how do you do that? So in your virtual service file, for your microservice that you want to define the timeout, so here you have defined your microservices recommendation system. You will write this line of code, that 1 second timeout, right? So with this, when someone is sending request to recommendation, if it takes more than 1 second, the Istio proxy will just return 3. The next part is retry. So basically now your request has failed, right? So you would want to retry. So rather than writing your own code logic that if my request to recommendation service fails, then retry for 3 times before actually finally responding with error to the user, you can add this piece of code here that make 3 attempts, and for each retry, this is the timeout. So then this system will make 3 attempts to recommendation service, and only when all 3 of them fail, then basically it will be done. The third part is circuit breaker. So circuit breakers are basically used so that you basically don't introduce cascading failures into the system. That basically one of your microservice was degraded, and basically if you are adding a lot of requests into the queue of that microservice, your all the requests basically they are blocked and waiting on that microservice component, that instance, and then your system will stop behaving, right? So you can basically create a circuit breaker logic that, like, for example, one example is that for a microservice, you will say that maximum number of connections it can have at a time is 1, and the number of pending requests it can have is also 1, right? So you will write it like this, that number of maximum pending request is 1 and maximum request per connection is 1, right? So with this, if a microservice has got one request and it is still serving one request, and if it gets another request, it will not add it to the queue, and before that only it will return failure, right? So then your system then basically can retry and send the request to another instance of that microservice, right? So yeah, so this is a circuit breaker. So with circuit breaker, a natural thing that comes to mind is spool injection, which is basically, let's say one of your instance of microservice was not behaving well, then you would want to throw that out of your pool, right? So how do you define that configuration, that how should the system decide that how it should throw out one instance of the microservice? So to do that, basically you write this kind of code that this will detect an outlier and that outlier will be ejected out of the system. So what this configuration is saying that check every 5 seconds. So at interval of 5 second check and see if an instance, if this microservice instance has returned 3 consecutive failures, then basically this instance is ejected from the system for 15 seconds. So then for next 15 seconds, it will not get any request. Yeah. So this is pool ejection. And yeah, I think these were the 4 main components: load balancing, timeout, retry, circuit breaker, and pool ejection. Any questions in these?
One tip I would say is when you're setting timeout, retry, and circuit breaker, be very careful and work with the ops or DevOps team, and because any changes that you do slowly and understand your system, and because each change will have drastic effects, cascading effects. So just because you can, you shouldn't do it. You should understand every cascading impacts that it may have on it, especially circuit breakers or timeouts. If you know that underlying system will take sometimes more than 3 minutes and you put 2 seconds, and it generally takes 3 seconds or 4 seconds, then you should be set configuring that, otherwise your whole production system will come down. And making these changes, even though it looks small, set up a meeting and then make the changes. It looks simple, but it needs lots of understanding the system. Configuration is easy, but understanding the system before you do it. Just because you can, you shouldn't. We learned it the hard way. Least to say.
That's a great point. I definitely agree with that.
So you're talking about the timeout, right? Or no?
Sorry, timeout and retry and circuit breaker.
Okay. So probably
and also in circuit breaker, right? The 2 aspects of it. This is one Istio circuit breakers, and also you have your internal service circuit breakers, where you have to not call the cascading service and call some other service.
Okay.
So you have to understand how your service works before you implement the circuit breakers.
So the idea will be generating a V2 versions if any code changes happened, and then test it if timeout is increased or not, like then deployed it, right?
Yeah. Yeah, and you can use observability, which we will discuss later, to see what are the typical timeouts of your new system. And then based on that, you can define the threshold. And typically we have seen this is the latencies of this system. So then our timeout value should be this. So
see this sidecar provide a different dashboard, or is it together with your pod?
So this Istio, it uses basically for dashboarding and all. So when we will come to observability for tracing, it supports both Zipkin and Jaeger, right? So let's discuss more about this when we come there. So
Sure.
there are some common tools it uses. Yeah. Okay. So before we go to observability, let's quickly go to chaos testing. So basically, chaos testing is that basically you are testing the strength of your system, even if in very bad scenarios, right? So if a lot of things fail in the system, how is your system able to recover from those kind of scenarios, right? So for that, you have to be like, you would not want to actually wait for those kind of scenarios, but you want to artificially introduce these kind of faults in the system and see how your system is doing, right? And so like here we will discuss two kind of issues. So basically HTTP errors, which is that a lot of your instances of microservice are returning HTTP errors. And then you want to see how your system is behaving. And second is delays, that a lot of your instances are taking a lot of time to respond. And then you want to check how your system is behaving over that, right? So to introduce HTTP errors, basically you will add this configuration that for HTTP request that comes, introduce a fault, and the fault is that abort the request by HTTP status 503, and this is the percentage that how many percentage of request should basically abort by 503, right? So when you have this configuration, then when anyone makes a request to recommendation service, 50% of the request will behave normally, how they should behave, and 50% of the request will return 503. The second part is adding delays. So again, so this is another flavor of fault. So in fault here you will say delay, and the delay is fixed delay of 7 seconds, 50% of the request. So again, 50% of the request will have 7 seconds of delay, 50% will act normally. Okay, so this is another great tool that developers can leverage to see how the system behaves in these kind of issues. Okay, moving on to the last part, which is observability. So, so observability is basically in this, all the metrics and traces, they are reported in the Istio mixer, right? Just a reminder. So this Istio mixer, which is running as a different microservice, everything is reported. So, so in observability, there are three kind of functionalities that the system provides. One is tracing, second is metrics, and third is service graph. So does anyone want to explain what exactly is the meaning of tracing and why it is very important in distributed system? In non-distributed system, it's very simple, but in distributed systems, it's called distributed tracing, and the things are not simple. So basically what happens is like your request will go from one microservice to another microservice. And let's say you want to see the order of your request, that a particular request, how did it go from one system to another system, right? So basically like a simple approach that comes to my mind is that I'll do some ordering based on timestamp of the logs. So every system will have logs and I will order them by timestamp, right? But the thing is that you cannot rely on timestamp because there is very small latency between these requests. And if there is some little difference between the clocks of these two systems, then your traces will not be properly ordered, right? Because if it came from one system and if its clock was little bit ahead and then it came to second system, if you sort them by timestamp, then the second system's log will come before the first system, right? So you will not be able to reason them. So that's why we use a system of distributed tracing, which basically creates a kind of a graph. So a graph is an acyclic graph of what was the overall path of your request, right? So with this fundamental understanding, so this here in Istio, it provides a functionality to let you track the dependencies across the mesh of your services. And this tracing is programming language agnostic. So someone had the question. So it's programming language agnostic. You can use any programming language. And so it uses both Zipkin and Jaeger. You can use any one of them. So yeah, so basically just a little bit details about Jaeger tracing. So Jaeger implements open tracing format, which is a vendor neutral tracing API. So in that, there are few definitions. And once we understand this definition, then it will be very easy to understand how will a trace look like. So Jaeger has a concept called span. So basically a span is a logical unit of work that is performed in one microservice. And basically it has the start time, that when the request came to that microservice, and what was the overall duration, and what was the name of this operation, right? So this is a one span within a microservice, right? And then basically spans, they will be ordering between spans. So a span within one microservice, and then that request is then forwarded to other microservices. So there will be a relationship that it came from this parent, and then it went to this from this parent to this child, right? So there will be an ordering of your spans. So a trace is basically a data execution path through the system, and it's basically that directed a cyclic graph of all the spans in your system. So with this kind of a system, you can easily track the flow of your request and see how it went overall in the system, and then gain insights of how your system was doing. Any questions on this?
So one question actually I can ask. So yeah, you said like this tracing capability. So with that, like if the events are happening on multiple say units or multiple component, and they're happening in different time order. So are you you said something like yeah, graph is plotted, but are there like a kind of like time can be maintained, like it's a like something that this shows okay, this occurred at this time and the next one occurred this time or something like that, or how does it work?
Yeah, it will have the information about the timestamp. So the timestamp will be the timestamp of that machine on which that microservice was running. But what I mean to say is that you cannot use that timestamp to order your all the logs, right? Because there can be some skews in the timestamp. So you have to use a different mechanism to order your logs, and that's what distributed tracing brings.
Oh, I see. Okay, okay. So yeah, so I guess it is something like wherever the trace is occurring, they send their like a log string or something to this service, and that actually does the logging, real logging, something like that.
Yeah. Yeah.
Okay, okay, okay. Thank you.
So I have one question. So, the sidecar, suppose we are using for some kind of a token validation for a security purpose. So if I want to validate and then push some logs into a Splunk, I can implement a Splunk library and implement, right? Or it support only the Jaeger or something.
Yeah, I'm not sure about that. Does
Okay.
anyone else has answer about it?
Sorry.
Okay.
I have one question. So, does it provide like at any point of time what all services are in the critical path? As you said, this is a graph, right? I mean, when requests are coming at runtime, a certain number of. Okay. So, is it part of service graph? You want to say?
Yeah, it's part of service graph. Service graph. Yeah. The second part is metrics. So metrics is basically the numerical values, right? That how much was the latency and everything. So basically, Istio uses the data from the tracing information to basically gather all the metrics, and then you can use these existing metrics platform like Grafana and all to actually get overall metric information in your system, right? Because in the tracing we discussed, it has this information that what was the duration of each of the requests, right? So it's just now making a good use of that information to basically format that in the form of metrics and then report metrics to the system. Yeah, so then the last part is service graph. So service graph, I don't have actually visuals of it, but basically, yeah. So service graph is the functionality which this system provides, which shows the connection, that how microservices are connected to each other in your system, so that like you have a holistic view of what are all the microservices and how they're connected to each other. So again, you can see that in the form of a visual dashboard to get better information about your system. So yeah, I think this was about observability. The last part was about security. I don't have much information about how security is done, but yeah, from my side, these were the things I wanted to share.
So, one question here. So, this service graph, is it just show like what's the network? I mean, which consists of basically services and then the connections basically.
Yeah, it shows. Yeah, let me see if there is. Let me show you one visual of how it will actually look like, and then maybe you can better understand it.
So basically, what we did, the Prometheus and Grafana, right? So once you have that information in Prometheus from the sidecar, which is all you have to do is, it's up to you how you want, what you want to visualize in your service graph, and whether you want the service metrics or you want the operational metrics like counts, or you want much more details about the service. So health of the service, everything you can track via your, it's like the open raw materials that are provided. You can actually build whatever kind of dashboards you can. And also there are some other third-party tools you can integrate where you will get different connected metrics.
Yeah, I think that's a great point. So service mesh out of the box, it won't provide you these visuals and all. It will provide you data, and then you can use these third-party tools to plug into the data and then show you in more visual form. So like one of the example is one of the tools is Kiale, which you can use to then basically see what was the overall flow graph. And basically how the overall flow was, that information is already there in the traces. So it's now a matter of someone utilizing that information and then creating a visual out of it. Right?
There is one more thing called App Dynamics. You can actually use that. It will also give, but you need to configure that at a different level. You won't be using Prometheus or anything. You can add that, and that will get much more richer dynamics and machine learning and everything, but it's a paid version, but we use that. And that will give lots of leverage over it, over the data that you have.
So just a generic question. So sidecar, I heard like it can be, if I have a 5 microservice, it is a kind of a reusable component, which will be part of every microservice component, right?
Yep.
Yes.
So
yes.
Suppose if I want to modify a small code changes, so it is actually a overhead, right? I mean, deploying this code change to 5 a component again, right? Is rather than an isolated service, same component, it's a single deployment we will able to achieve, right? Otherwise, we have a multiple deployment. Is that something true or?
So with sidecar, you have these common functionalities, not your application logic, right? And so in your business environment, you will be making a lot of changes in your application logic, but these common functionalities, they have been actually verified and tested for a lot of, basically these have been verified and tested. So I don't see that you will be making a lot of changes in the code of NY sidecar, but you will be making a lot of changes in your service, right? And there, like you will have to only update your service. And the other changes you will be making is in the configuration files, which are here. But yeah, like if once in a while, if you want to update the logic of sidecar itself, the common functionality that is being used, then I believe, yeah, then you would have to update that in all the microservices because that is the common functionality being used by everyone.
Okay. So can we have an inbound sidecar and outbound, like 2 sidecar in a 1 port, or is it only single support? Like I wanted to validate some common functionality, and a request comes to the before coming to the pod, then after the pod before sending traffic to the next pod.
You can do because sidecar is basically a YAML file that you append to the actual service, and it is up to you how you want to build the sidecar. So in this case, you build the sidecar for connecting to Istio. In other way, you just use sidecar to move the logs. In other case, you can just want to move your error logs as service metrics, right? It's up to you how you configure the YAML file, which is nothing but a sidecar. And the sidecar, you can consider that as a library, which you'll be using in your service. Okay. You can make that common so that you'll standardize. So if you're in a DevOps model, right, you want to have standardized logging, standardized security, standardized routing. So you will create and develop these sidecars, and you can have different version of sidecars in your system. Like we had different sidecars for different kind of applications. Some of them are internal, some of them are external. So external needs to be more hardened, right? Mm-hmm. Just to be safe, and those needs to be having much more security certificates and authentication, authorization. And whereas internally, when you're using it for intra teams, you don't need to have that much of security, and it may not have that much of PII or CPNI data. Then you don't have to worry about it much. So your sidecars can be same or can be less rigid in the lower environment. So you configure it. You can have multiple versions of it, and you can change it.
Thank you.
It's just a YAML file.
Okay.
I have one question here. So just now you mentioned, I guess, if Istio version is upgraded, right? So let's assume there is some new functionalities they are providing, and if the system wants to upgrade to that version, then how it will be done? I mean, that upgrade process.
So that's similar to whatever happens if you change for HA proxy or log4j or any other. I'm mentioning log4j, but if you are a developer or if you are a project manager or a manager, there's a 0-day vulnerability with log4j that almost everyone has to make changes. If you don't know, there's a 0-day, it just happened yesterday or day before yesterday, your services are vulnerable for external attack. So you have to make the changes. You have to bump up the version of your service to escape from the 0-day. So things like that. If Istio version comes with a 0-day or some better features, yes, you have to change the version and apply it. But do test it in lower environment before you do that. But it should be just apply the commands, kubectl apply or something like that.
I think that it's a very good question, that if we update the version itself, like, because it is common, so we would have to update all of them, right? And I believe so that's the way it would be, but I don't know if there's a better way to do where we don't have, like, I don't know how actually.
Yeah, basically, if you're in one control plane and data plane, yes, that's the case. But every team may have a different control plane and data plane, so or you can split it out into smaller chunks, pilot, and just do that.
Yeah.
Okay, so now I have one more question. So as you said, that different team will have different data plane and control plan. So how the communication happen across control plans? So can you throw some light on that? Or I am understanding something wrong? I was assuming that control plan will be like it's common to the whole platform.
Yeah, even I also think so, that it's common to that entire that microservice system. So you have one control plane. So Praveen, can you share your experience how your team had different control planes?
So basically, you have common. If you are one team, right? In one team, you can have one common plane, or you can have multiple common planes depending on which services you are, or common services. So you may have shopping cart, you may have experience, you may have different one. So you may have different control planes, or within that you may have multiple ones, but each one is an entity of its own. Sometimes initially you may just create one control plane for one kind of service A, and one control plane, or you can have group of simpler services in experience in one control plane, so that you can take ownership of it and observability. So within one team, so it depends on your team and number of services you have, you can customize it. So if you see what's happening, right, in the initial destination rule and everything, you configure which kind of services reside in the control plane and what it needs to control. You don't want to add payments and shopping and everything in one control plane. That will be bad, because you want to isolate or minimize the failures if everything happens in one. You don't want to put all the eggs in one basket.
Control plane is the place which has like all the common things that Istio system should know. So the common things is like service discovery, basically knowing that which microservice has which component, and so that then it can route the request based on those instances, right? So these things, they will only make sense if they are shared and common across all of them. And I think this is also the represented in the diagram, that each of the microservice, they have their own envoy sidecar proxy, but which is part of data plane. But the components in control plane, they are shared. So everyone is sharing Istio pilot, everyone is sharing Istio mixer, everyone is sharing Istio CA. All the logs are going to Istio mixer. So yeah, so I think if these components are also in all the microservices, then it will not make sense, because these are the common things that they want.
Yeah, that's what I said, right? The common things they're putting in one.
So Praveen, are you referring to DOMA architecture, where like domain-driven microservice, where you like kind of there are a group of microservices which are very dependent on each other, so they will be like kind of a cluster, and communicate with that cluster. You have like front-facing microservices. Those will be okay. So then, what I think is there will be multiple control planes which will basically handle those clusters. I mean separate clusters. And then there will be a common control panel, which is just connecting the front-facing microservices to those clusters. Is it something kind of that kind of architecture you are referring to? Or?
Yeah. So let me. So what I explained is, see, if you see here, right, you have services, service B, service C. So if, or you may have services, service A in the same control plane, but that doesn't make sense. But during the testing, you'll do that. And you may also have different technologies, right? Some teams may have this, some one Istio implementation, some team may have different implementation or different, or you may use the legacy service, correct? Legacy implementations of whatever you're using today. So Istio will just provide you an endpoint that you need to connect. So from your service, you'll just change the configurations to point to this Istio. But within the team, you may have different ones. So what that does is, if you're connecting within the same A, B, C, then you're good. And if you're coming from outside world or any other service or within the orgs, right, you may have different ones. Then you will be trying to connecting to this pilot. This pilot will route it.
Okay. So okay. So if I take a concrete kind of stuff, like let's assume there are like 15 microservices, right? And then let's assume that 1, 6, and 11, those are kind of the front facing. The example I took, and then from microservice 1 to microservice 5, they are kind of interconnected, and their communication happens inside that cluster kind of. And then 6 to 10 are kind of one cluster, and then 11 to 15 there is one cluster. So now, is it so that there are 3 control plane, 4 control plane? One is like one control plane will handle from 1 to 5, second will handle 6 to 10, third will handle from 11 to 15, and then fourth control plane will just connects 1, 6, and 11. Is that something like that?
Yeah, you can configure it that way, but ideally, right, this not only Istio, right? In your ecosystem, you may also have APG, you may have other different kind of gateways or in API gateways that you will interact with, correct?
Right.
So just because you're moving to Istio doesn't mean everyone is moving to Istio, correct?
Right.
So you can't force, just because your team is advanced, you can't tell other teams to move and you are moving this service. So the endpoint will change, but within anything within this Istio will be one package. You are the best because you developed everything, resiliency, observability, chaos monkey, and everything. But others may take some time. So they will have an interface and you'll just point that in your properties for discoverability.
Understood. So in terms of upgrade, so we are saying that there will be total complete system and downtime basically, right? For some time when we upgrade this, that's what we are saying, right? Finally.
What upgrades?
If I upgrade the version basically, the sidecar version,
Yeah, within that one, yes. But Kubernetes will handle that. When you're doing apply, it will make sure it'll at least keep one version running before it builds the other one up, and then slowly it offloads the traffic. It will try its best to not to drop any traffic, right? That's the beauty about pods.
Okay.
Yeah.
Okay.
Okay, I saw a hand raised from John. Do you want to ask your question, John? If you're still in the call.
Sure. I mean, I think you answered some of it though, but I had two really simple questions. The first one though is this one's what if your pod wanted to go outside of the sidecar and want to communicate without going through it? Is that just a configuration change?
Yeah, I am not sure how that will happen, but I think if it is,
if your pod wants to go, what does it mean go? Means
If it wants to communicate not through the sidecar, if you want to bypass the sidecar completely, is what I'm asking.
Yeah, you can do that. You can just remove that from the YAML, and then you may need to custom set the routing and all that other things, and you can still do that. Then it will be like any other regular Kubernetes pod, right? Is
Right,
that
cool.
what you're saying?
Yeah, that's
you
what I
can
was
remove
asking.
that. Yeah, you can decouple that one pod and from this and just keep it as. So then your control plane will not be monitoring it, and it will be like an independent service running on its own.
So I don't want to disconnect the pod entirely from the sidecar. What I'm asking is, like, let's say that my application knows of another pod that's not inside of the same architecture, and I don't want to go through the sidecar to access it, but I want to maintain the sidecar to access the other pods that are inside the same system. Is there a way to like cherry pick your requests to have the majority of them go through the sidecar, but have select few go out?
Generally, that's not the best practice, but since it's YAML, you could do that. But because of the observability and the routing and discoverability, you may have to override the sidecar features. So even though you have a sidecar, right, in the YAML, you can overwrite that if you have the same files in your local, and you can overwrite the sidecar settings with your local file. That way, even though you are in the sidecar, you have your custom settings.
Okay, yeah, that makes sense. I guess I'd have to dig into that a little bit more. I'm just asking out of curiosity, because things work great when they work exactly like as you plan, but it's those side situations that are a pain.
Yeah, when it works, but when you want to debug, and that's when it's the pain. But that's why before you do anything, you need to have a very good dashboards and observability. And that's why the sidecars are good, because out of the box, everyone is going to see the same service in the same way, the metrics in the same way. So if something goes down, you want to analyze the same way. If you have custom observability and logs, then you may not have the same capability or visibility to see that your custom ones. So if you may be doing good or bad, but you cannot monitor it in the same level.
Thank you. And my second question is this one might be a little tougher. We mentioned at the very beginning how microservices have a problem where they communicate over networks are unreliable, and we're trying to satisfy those problems. It seems like the service mesh system, though, itself actually adds more network communications. And
yes,
I'm trying to understand how it improves that problem, though.
It would increase the delay by at least half a second, but it improves the network reliability.
Really?
Because of
why
that.
Do you think that? Because this envoy sidecar, right? It is living within that. It's part of that microservice, right? So
yeah, it is part of that microservice. So imagine as you add even one layer, right? One layer of any extra layer, if without Istio, right? Supposing you're connecting from application layer to service to backend database, right? And inside middle, you add some other Istio and multiple services layers. So there will be definitely a little bit impact we saw when we did it. But the advantage that we got was resiliency and all the other performance. We were never down for last 1 year, and all our deployments were straightforward. We did A/B testing, mirror testing. So the few seconds that you, or maybe half a second, or 1/4 of a second that you lose, max 1 second, you will gain by having the reliability that service can take any peak volume, and it will never go down.
So are you saying that it improves reliability of a network because it takes off the dynamic possibilities of each individual service having its own individual timeouts and latencies and things like that, but then it just kind of uniforms it inside of a single service. So now that one service controls all those things. Is that what you're saying?
I mean, yeah, the reliability, yes.
Okay, cool, thanks.
Yeah, so basically I was just reading some documentation here, and maybe I can share that. So for this question, so basically they are saying that Envoy proxy uses this much CPU and this much memory, 50 MB, right, per 1,000 requests, and it adds like 3.12 millisecond of 90th percentile latency. So yes, it does add some latency, but yeah, to Praveen's point, overall it increases the reliability of your system because you now have retries and everything. So
it doesn't look like, very significant though.
It's like the kitchen to the table, right? Where the food is cooked versus where the person is served. As you add number of floors between it or distance between them, out here you have multiple layers, right? You have a authentication layer, security layer, gateway, load balancers. Even one extra layer will actually add a little bit more time for you to get your food from kitchen to your table. So you may have the fastest runners, but it will take a little bit extra than you eating directly in the kitchen. The food directly from the cook's cooking table.
That's
okay, cool. I'm asking
that's how our director told us.
All right, cool. I was actually asking these questions because especially when you're dealing with applications that are very, very much dependent on on deliverability systems like mail delivery systems and things like that. I was just kind of curious because that latency can, if the latency was significant, it would have impacted that service's deliverability.
Yeah. Right.
All right, thank you all.
Thank you.
So this is built in Java, JVM, or
no, this is one example that let's say your container is running in a JVM as a microservice, and so then I think Envoy sidecar, it need not be in Java. I think it supports other languages also. Praveen, do you know if it supports other
this
languages?
is out of process service then, right?
What is the question?
So Envoy sidecar, is it only supported for Java or is it supported for other languages as well?
I think it is language agnostic because it is just a container, right? Whatever you can host in the container, it can be AngularJS or it can be Java or it can be any language, your .NET. It's just a pod that you're managing, so it should not contain the services within that.
Okay. So it's out of proc service basically. Okay.
Yeah, it is outside. It's a different component and it is attached like a sidecar. So it need not be in the same language as yours. So that's why you see that JVM, they have in this diagram, they have shown that service A is running in JVM, right? But they have not shown that Envoy sidecar is running in JVM. Okay. Are there any more questions or anything anyone wants to add?
Hey, this is Guha. We talked so much about the sidecar. It's just a design pattern, the sidecar pattern that's implemented in this context, right? It's the same thing, right?
Yeah.
Okay. Right. Hey, excellent presentation today. This was awesome.
Okay. Thank you.
Abhishek.
Thank you, Abhishek. This is a good one.
Yeah, Abhishek, thank you. That was awesome.
Thank you, everyone.
Thanks for this presentation. Yeah, that's great.
I'll stop recording.